Good afternoon, everyone. Welcome to the second part of our undergraduate research series. So today we're very lucky to have Dr. Gilad Feldman, assistant professor from the Department of Psychology at Hong Kong U, to give us a talk about open science as well as his project on Hong Kong U registered reports. So I'll only use one or two sentences as Gilad wanted. So Gilad's work is in the area of social psychology, judgment and decision-making, and his research focuses on topics of biases, heuristics, especially regarding agency and action. So Gilad, on to you, please.
Yes, thank you. Thank you very much for this opportunity. I'm very glad to have a chance to talk to you about something that I'm very passionate about. And also good timing for us because it allows me to kind of announce a project that I've been working on for 3-4 years now, and finally got some support from HKU to get as many people on board as possible. And it's very much aligned with the CETL kind of goals, aims of involving undergraduates and students overall in our research process. Much of what I've been doing since I've joined HKU, started teaching in 2018, is to use the classes, the courses that I teach, and the thesis students that are working with me, the undergraduates and the masters, in order to mass mobilize students to doing actual hands-on research that is also publishable and can address all sorts of challenges that we're going through right now in science, which I'll briefly address. In the spirit of open science, everything is open and shared, so you're welcome to download the slides. There's lots of hidden slides. There's, I think, 120 slides in the background. So please do download this. Lots of clicks, links that you can go and follow. And of course, if you have any questions, you have my details in here, and I'm happy to follow up on any of these. We'll do a Q&A at the end, but if you have any questions during, I'll try and keep an eye on the chat, but I'll address all of this at the end together. I just want to say that all the talks, hopefully this one as well, is shared on YouTube and on the Open Science Framework. So you can see all sorts of other things that I've been doing, but open science is definitely the main theme over here. Today, I'll focus on two main things that have to do with this project that I'm promoting. As the theme of this session is about student power. So my main aim is to show you that students can do science that meets the highest standards in our field. My field is social psychology, judgment, decision making, and we can get their work published in top tier journals. Since stuff is going on in science, I want to make the claim that students are the key in order for us to make a real change in the way that we do science and improve our science methodology and practices to get to higher integrity, higher credibility kind of science. And we should be working with students. Students are the key to the science foundations and doing high integrity open science. The way that we're going to address this topic is through this project that involves a register report. And the main claim is that this is a revolution in science. You should know about this if you haven't already. And not only is it good for science, but just so happens that it's also good for your career. Students can publish, but also you can publish. And there's some very, very strong benefits. I'll start from the bottom line of what is this HKU Register Report Challenge? Where does this come from? So in 2017, I was a postdoc at Maastricht University in the Netherlands, and I really didn't know much about open science. I got the indication based on all sorts of things that happened in the Netherlands. There was a big fraud case, and then they decided to really take this on and promote open science and be leaders in the world in open science. So I understood that there is stuff that's going on. We need more replications. The replications are replicating as high as we would have expected, but I didn't know what to do about this. And whenever I thought about, I want to do a pre-registration, I want to know how to implement open science, there were lots of barriers to that. And I really like the Center of Open Science that opened in the last 10 years, really trying to promote their open science practices. And they came out with this thing that's called a pre-registration challenge. And basically what they offered is a cash prize of $1,000 US, saying that if you have a publication that used pre-registration and it arrived at a journal, then you are eligible to receive in a lottery or some process that they have the possibility of receiving $1,000 US. I took this as an opportunity. I was able to convince one of the master students working with me to embark on this journey. This was the first time that I ever did this sort of thing. Very glad that he joined me on this journey. And luckily for us, first time I ever did a pre-registration. And not only was this a pre-registered study, it was also a replication. So the first time that I ever did a replication study, and it got into a nice journal that's reputable in our field, cognition and emotion. And the nice thing about this is that soon after, Lucas already graduated his master's, and then suddenly we got this, you received this prize, $1,000 just for doing a pre-registration and getting this published, which we used in order to fund some other stuff in the future. And since then, I've never looked back. So since 2017, because of this challenge, I started doing a lot of these things. So I really like the Center of Open Science. This kind of thing is that, first of all, make it possible. So now it's very possible to do pre-registrations, make it easy, make it normative, and make it rewarding. So for me, I really needed this making it rewarding sort of approach. So what is it that I'm offering to everybody at HKU and beyond? Is that I'm funding your data collection. So let's say that you work with students, up to 30 students, 30 projects. If you submit this together with your students as a registered report, and this is related to my field in some way in social psychology, the JDM, which is nice because it really applies to both business, education, sociology. We can think of all sorts of links and ties, but if you do a registered report with students and you receive an in-principle acceptance from a journal, and I'll explain exactly what that is, then we will find your data collection. So I will help you do data collection up to $1,000 versus 8,000 Hong Kong dollars. Very briefly about the details, I'll come back to this later. It has to be a registered report. A registered report is not a pre-registration, it's something different, and I'll talk about that. It has to receive an in-principle acceptance from a journal in order for you to be eligible for this funding. Students have to be co-authors. So if there are no students, then perhaps you can get your own funding from somewhere else. But it's important for us to empower the students and get them to endorse a bit more of these revolutionary open science practices. And we do believe in open science. We try to promote open science. So everything from this project needs to be shared. So anonymized data sets, all the code, all the materials need to be shared on the open science framework publicly and permanently in the records. It needs to be related to some of my domains, but this is a very broad domain, so I do all sorts of different stuff. The data collection, I'll show you how I did all this project so far with students. Should be conducted on Qualtrics online. So we have a lot of experience with running this on labor markets like Amazon, Mechanical Turk, and Prolific. There's some limitations to that, but I think almost everything will be able to address. How much funding? 8,000 Hong Kong dollars. Typically, if you have, like, my experiments are typically like 5 minutes and you have 1,000 participants, 8,000 Hong Kong dollars will cover that. So 1,000 participants for an experiment is very well powered for most of the research questions. And we have about 30 of those, and I will conduct your data collection according to the best practices in how to achieve high quality data collection. And we can talk more about that. We have a lot of resources. So I've had 4 years to develop these things with my students and my team. So we have some templates. Please do go and check out these templates. It will really make your life a lot easier on how to do these registered reports. We also have a lot of guides that you can check. The way that we address authorship is that you can do your own registered report, but if you want to join our team, it's a very large team, lots of people, lots of experience, you can join us, and then we can talk about collaboration and authorship. But the most important thing is, of course, all students must be co-authors, and if everybody who was involved in that project, sometimes we don't credit our research assistants or teaching assistants. Us in this project, we credit anybody that was involved, including teaching assistants, including the students, and there's something called a credit contributorship, so that needs to be in that project of yours, in the submission. If you want to be involved in this, you contact me. We can make sure that you meet all the criteria, but it's fairly straightforward. There's not a lot of limitations. It's fairly open, and we can talk about any concerns that you might have. So the first claim, that was kind of like a teaser of what it is that we're talking about over here. The big claim is that we should really empower our students, and students are capable of remarkable things. I think we were talking before about my Twitter activity, and I think one of the most remarkable things that happened through that is that I just started sharing everything that I do with the students. Students do everything on Google Docs. So whenever a student submits something, I go on Twitter and say, a student did this, go and have a look. If you have some comments, give us some feedback. And people from Twitter started going in and seeing what HKU students are doing in my courses. And it just blows your mind. If you set the path, if you tell the students what you're aiming for, what the goal is, and then they're able to do remarkable things and achieve what I consider to be high quality publishable science, we're able to get this to journals. And I've come to the conclusion after 4 years with HKU students that students are really appreciated, underutilized stakeholder, and we should really involve them in everything, rather than us telling them what the truth is, and us with our PowerPoints and bullets telling them what what our knowledge is. We should invite them on a journey in order to discover and work together. After 4 years, what have we accomplished in my courses and with the thesis students? So far, we've done 80 completed with data collection, pre-registered replications and extensions. Plus, we're here talking about registered reports. So about a year and a half ago, I shifted from pre-registered replications and extensions with data collection to registered report model, where they write registered reports. So far, we've done about 30 of those. Based on our experiments and experience, we've conducted about 80,000 participants data collection, and based on the budget the very small budget that I have, I was able to utilize this about $1 per participant. So in 5-minute experiments, we pay a federal wage salary, minimum salary in the US, that's $7.5. So if you divide this by 60, multiply by 5, it's about like $1, plus you need to pay all sorts of things for Amazon. But this is generally the scope of this project. Now, typically when I talk about this, people say it's great that you did some research in your courses with undergraduates and master's students, but how do we know that this is high quality? How do we know that students are doing something that is publishable? So at the beginning, the first 2 years at HKU, you needed to take my word for it. I really did not have any evidence that this is possible, aside from what I did with master's students in Maastricht University. But now we have a lot of people from around the world that joined us here at HKU. You can see that we have over 75 early career researchers from various parts of the world, from mainland China to Brazil. We're hoping to have more collaborators from Africa, Central America, but generally all of these are early careers, so master's, PhD, postdocs, and early assistant professor tenure track like myself. You can see that up till now, I've had 36 guided thesis students and about 370 students that participated in my courses. And as you can see, this is what we've achieved just in the last year. So in 2021, all these are students and early career researchers that have come together with me to publish work and submit this to journals. So you can see that our model generally is that all the underlined ones are my students in my courses. And after they complete the coursework or the thesis work and they have something that's ready, I go on Twitter and I say, this is what our students are capable of. Do you want to join us? And I offer them to take the lead. As you can see, they take the lead, but it's shared first author with this star. So the early career researchers and our students at HKU are shared first author. The lead authors come in, they verify everything, they make sure that it's submission ready, they make the introduction and the discussion a little bit stronger, and then they go through the whole thing with revisions and the journals, and this works brilliantly. Now we know that this works. So this is an early career researcher. So most of the first authors here are early career researchers. All of the underlined are students. Back at the end, some of them are my teaching assistants. So teaching assistants, as you can see, also get some credit. And everything is shared, Open Science Framework, preprint, and the article itself, so you can go and have a look at any of them, any of those. Now, March 2022, we've had about 5 of those, and there's many others that are in process. Till now, most of these manuscripts, as you can see, are pre-registered replication and extensions. How many of those are what's called a register report? Unfortunately, until now, it's only one of those done together with the students. This is an MPhil student that was very brave to join me on this register report journey. I was asking a lot of people who is willing to do this register report with me, and he was very enthusiastic. We submitted this, and this took less than a year from submission to finally an acceptance and a publication of the stage 2. So very, very efficient. And to do this during an MPhil is terrific because it prepares them for a PhD, and very competitive around the world to get into a PhD nowadays. But I have a lot of experience with registered reports, not with students in other projects. I want to show you just how many registered reports we have ongoing right now at the moment. So we have 16 of those. Many of those are me and my thesis students. So all of my thesis students, undergraduate and masters, are doing register reports. So that means that all these theses are going to be published as an article. And this involves a certain way of, we're using something called peer community in register reports, which guarantees peer review within 2 weeks, but we'll get to this at the end. This is just to show you that there's a lot going on, and I am very committed to working with students in order to achieve register reports and student-led publications. Yeah, thanks for the clarification about register reports. So I'll get a little bit to that. So what I wanted to show you is that after we've conducted these replications and extensions, we've done about 80 of those. Do we have some summary of all the findings of what we did? So all these are from judgment and decision making. We've replicated classics in the 1970s up until the 2000s. And what is our replication rate? So our success rate is about 68%. Now, I don't know what you think about this figure, but this figure is a lot higher than the replication rate currently in most of the fields. So aside from judgment and decision making being perhaps a little bit more solid, at least the classics compared to everything else, I want to emphasize that this really shows that the students have done remarkable work. Not only is the replication rate high, so at the beginning, people were very skeptical. Can students do replications? Will they be able to understand everything, repeat this, get the same kind of results? So they could in a very, very high rate. But not only this, but also in the mixed and inconclusive and the unsuccessful ones, they were able to identify all the possible reasons for why this didn't work out and really find errors between the tables, the figures, and the text. They were able to find statistics that don't make any sense that led to an issue of expression of concern. The students did a remarkable job, not only in the successful one, which is very high rate, but also in the ones that didn't work out, which to me is really very strong evidence that these students are capable of wonderful things. I want to show you what this looks like, but please bear with me. We'll get to like a live demonstration of what this register report looks like a little bit later. For now, I want to give you an invitation to just look at these reports. So if you scan this, if you click on these links, you'll be able to see what a register report stage 1 looks like with our students from the last semester. There's one from, so this is 2021, this is 2020, and then you have 2019. In 2019, all of these are also with data collection. So we'll be able to see an APA style submission ready manuscript with data collection that ideally should be able to submit to a journal. We don't submit those, we invite early career researchers, they verify everything. And then we jointly, early career researchers and the students, submit this to the journals, leading to publications. Now, you don't need to take my word for it. Perhaps this is not very convincing coming from me. Let's hear this from the students. So you have the opportunity to go and listen to them. We've had in the past 3 months, quite a few of the students that did their thesis work with me. So Nadia did her undergraduate thesis with me. And just today, a second paper. So she took the undergraduate course with me, and then she did her undergraduate thesis with me. So her undergraduate thesis, you can see already here, was accepted for publication in this journal. But today, we got notice that what she did with us in the course was also accepted for publication. So it's remarkable, for an undergraduate student to have 2 publications, and now she's a PhD student in the social sciences. So she stayed in academia, and this hopefully led her to adopt the foundations of open science in her future work. Cora was a master's student. It's ironic that sometimes our master's students know less statistics than our undergraduate students. So she came with very little information, coming more from the industry, but very fast, within 1 year, she was able to do this remarkable replication of this old classic, and this finally in one of the most reputable journals in social psychology, was able to get this to a publication with the help of an early career researcher. So wonderful. Not only do we have YouTube videos for you to listen to them talk about their experiences and see how meaningful it was for them, we also have a Psychology Today column. So Rihanna, also an undergraduate thesis student that worked with me. And here she reflects about her student perspective about her journey in open science to replicate a classic phenomenon in decision-making. And this also was later published in a journal. Now, this might seem like magic. So, when I give talks about this to some people from around the world who have tried to work with undergraduate students and, publish with them during courses, so how is this possible? How to make this happen? I give workshops on this that take 3 hours, half a day, and we can go into all sorts of details. But the good thing is that all that I'm doing is actually shared on the open science framework. So in the spirit of open science, not only is my research shared, but also everything that I do with my teaching is shared. So if you're thinking of working with students and you're not sure how to do this, just go have a look at all the syllabi that I shared, all the presentations, go and see the students' work. And students that are coming into my courses have to adopt this open science spirit and know that everything that they're doing in my courses is shared openly. I'm kind of privileged in the sense that I have an elective or I have a capstone, so I can have these kinds of demands. But I also taught fundamentals of social psychology, and over there you can kind of like discuss this with them and get their approval, and then come to a solution where all of us are working together and everything is shared publicly. But please do go and visit and see how this is done. If you want to see the summary of 3 years of us doing this, so this is a 3-hour presentation of how I did this. So I gave this workshop at HKU. If you missed it, you can go and have a look. If you want a more brief version, then I explained this to the folks at Oxford, reproducibility. So it's how to discuss reproducibility in Oxford, a T Club. So you can go and get the 40-minute version of that for me to summarize this. So hopefully this convinced you that working with students and bringing their work to publication is possible, and that you can gain the students' perspective. And trust me when I summarize what they've said as a very meaningful journey that changed their perspective both about education and about science, and led to long-term changes in the way that they think about being involved in research. So that was my first claim. It is possible to work with students as early as undergraduate, second year, and we should do a lot more of that. And there are possible benefits also, in terms of the impact on science with the number of publications and the involvement of a big team of early career researchers from around the world. So it's possible. Now I don't need to kind of say, trust me, now I can show you that we've done this. The second claim is about register reports, and this is what this HKU challenge is about. I argue that register reports are the future of science. I'm very convinced in this. I'll very briefly argue that there is an urgent need for a science reform. If you're not up to date with this, I give courses on why we need a science reform, what are the challenges that science is facing. And I argue that register reports are able to address these fundamental problems in a very convincing way in order to improve the science. And at the end, register reports, is just science done right. It's not only good for science, but it's also good for us as researchers as we contemplate how to assess researchers, how to promote best practices that really advance our knowledge and understanding to get closer to the truth. Many of these slides are adopted from Chris Chambers. So Chris Chambers is the person who initiated these directions, and he comes from neuro, on the border of neuroscience, bordering psychology, but now he's leading this charge. He started in 2013. Credit to him and a lot of others that are working on budget reports for building these slides. So these are not mine. And as an open science advocate, everything from his presentations is open. So I adopted this for here. So he talks a lot about this paradox, and I know that we feel this paradox very strongly at HKU. So what part of the research study do you believe that should be beyond your control as a scientist? So we want to seek the truth, we want to understand the truth, we want to observe the truth. So definitely when we conduct a study, we want to see what is happening. We don't want to influence this to be what we think it should be, but rather understand that this is how it is. Therefore, the results should be out of our control. The results should be, according to what reality really is. However, which part of the research study do you believe is the most important for advancing your career? So at HKU, we talk a lot about impact factors and a very selected list of 4-star. 4-star is what I keep hearing all the time, where I should publish and what I should aim for, and impact and contribution. So we evaluate things also based on results, because in order to get to all the science, nature, PNAS, and all of those, we need to show these novel contributions that go beyond, very sometimes counterintuitive, or show something remarkable and new. So on the one side, we are told and believe that we shouldn't touch the results, but somehow we're supposed to make these amazing. There's an inherent paradox in here, because you can't have both at the same time. And this really distorts all kinds of things in science. And this leads to inherent systematic issues that we need to address. What's best for science is high quality research published regardless of the outcome. However, we know that the science journals, the publishers, the editors, the reviewers look at our research, and one of the first things that they evaluate us on is the outcome. Therefore, we have to produce these outcomes. We have to have a lot of these great results. But of course, we're limited in time, we're limited in resources, we're limited in all sorts of things, money, funding. So a big problem. So how do we address this problem of getting great results? So we have this publication life cycle. So you generate hypotheses, design a study, collect data, analyze the data, interpret data, publish and conduct the next experiment. However, we know that in each and every one of these steps, we have problems. So now we have evidence showing that actually there's no replications when we generate and specify our hypothesis. Only 1 in 1,000 studies is actually being replicated. When we design a study, we don't have a lot of resources, so we do very small samples that are very noisy, and if something doesn't work out, we just put it outside to the file drawer. But then we increase our chances for the noise to find something that works out, that is p-value lower than 0.05. Selective reporting. So we've collected the data. We must make use of this data set and find something in there that would achieve whatever this science journals are looking for. So there's a lot of what we call now questionable research practices. So between 50 to 100% self-reports that they do selective reporting. So for example, don't disclose all the variables or don't disclose all the conditions. And then very, very common is that whatever it is that you found, you need to build a story that would convince the journal to take you in. So you change the hypothesis to say, what I observe here is what I hypothesized all along. Plus, big problem is that we have a very strong publication bias. So it can't be that 92% of our published findings are positive, p-value lower than 0.05, because just by the randomness of the universe and not every hypothesis being supported, where are all these things that don't work out? We just don't publish these. So big problems inherent throughout. How big are these issues? They're very, very big. I don't think we talk about these enough, not among ourselves and not with the students. And generally, when I give talks, I open with this slide. And the slide talks about an ongoing crisis, science crisis. We call this the replication, reproducibility crisis. And at the beginning, we thought maybe it's just psychology, the science of blah, blah, weak science, not really a science. But then we challenged the hard sciences, show us that you do better. And in the past decade almost, we've seen that actually one by one, the sciences seem to fail us. So not only in psychology, but also in medicine, in chemical research, economics, most recently, 2020 and 2021, in empirical computer science, which is as close as you can get to math, or in quantum computing and physics. But very concerning, and I'll talk about this, is the cancer research issue. So how do we know if something is credible or not? How do we know if we have a problem or not? We conduct a lot of replications and we look at the data sets and the code if they're available. If they're not available, we don't have open science. We don't really know where we are. So there's a problem that we don't really do and publish replications, and we don't really share what it is that we publish. So we don't really know how well we're doing. There are some first indications from all sorts of replication projects that have been conducted in the hard sciences. I won't go into these. I'll just tell you that these numbers are very depressing. I'll focus on this one, which I think was the most rigorous, cancer biology, published just very, very recently, like 3-4 months ago. These are the Twitter summaries of what they were trying to do and what they finally embarked on. So 2013, they say, let's try and replicate 50 of these. In 2018, it's like, okay, we can't do 50 because only 18 of them we are able to get all the materials, the procedures, and contact the authors for them willing to help us with this. And finally, 3 years later, how many of them did they succeed in replicating? Only 24%. So out of very ambitious project, claiming that cancer biology is more replicable and reproducible, we're left with a very disappointing finding that cancer biology, it's not psychology. If my finding is in judgment decision making don't replicate, I don't think there's like much harm. But can you imagine cancer biology, pandemic related, COVID related, if these things don't hold up and replicate? Very unfortunate. So cancer biology is not doing well. Social psychology, I would summarize this as about 30 to 50% replication rate. And if you compare this to what I showed you from the students, so you can see that we're about like double of that in judgment decision making. But this is just to say that our systematic reviews of biology, systematic reviews of social psychology show inherent problems. My main aim over here is to say, regardless if you believe there is a crisis or not, I believe that it's very important for us to reflect, reassess, and aim for improvement. So when I talk to my students, I try to get them to go with me on this journey. And I consider this just like this cartoon, when people are talking about climate change, so they're talking about green jobs and livable cities and renewables and clean water and air. And then somebody stands up and says, what if all this is a big hoax and we create a better world for nothing? For me, it's the same with open science. We're talking about things that are fundamental to science, like data sharing, reducing publication bias, preventing p-hacking, increasing transparency. And occasionally somebody comes up to me and says, what if all this is a big hoax, we don't have a crisis, and we created a better science for nothing? And my aim is to just create a better science and communicate this. How to do this? Register Reports comes to the rescue. If you want my 3-hour workshop on Register Reports, then that's also available on YouTube, since time is short and I need to be very, very brief. Back to Chris Chambers. So you can see in 2013, he decided to go on a new format of publication. He did this being an editor in Cortex, which is a neuroscience journal. And what he said was that the new thing about these register reports is that instead of submitting a finished manuscript with all the data collected to the journal, you don't submit a data collection manuscript summary, but instead you submit a plan. So you submit your pre-registration to the journal. Then you get peer review over that plan. You talk to the reviewers, you talk to the editor, and then you come to the best plan of how to test your research question. And when you all agree, the journal gives you an in-principle acceptance, meaning that it doesn't matter what the outcome is, p-value higher or lower than 0.05, doesn't matter what the results are, as long as you followed your plan, this will be published. So it sounds very simple. When I talk to my students about this, they're asking me, isn't this how science is right now? And I'm telling them, no, I'm very sorry. Somehow we needed to wait until 2013 and Chris Chambers to come up with this thing. But this is how science should be. So right now, a traditional publishing model is broken. You only submit this for peer review after you collect the data, after you write the report, and then lots of reasons to reject you because they don't like your findings, because they're in the opposite camp of, these findings don't align with theirs, because the findings are null, because it's a failed replication, because. And of course, a lot of these things about contribution. Instead of this, we can think of a different model where instead of first, running everything yourself and writing everything up, then we're able to talk to the reviewers beforehand. So from this very messy model, we look at this new model where we have two stages. The first stage is on your study design, your pre-registration, and only after you get an in-principle acceptance, you continue and collect your data analysis. And the stage 2 peer review is only to check whether you followed your protocol. So nothing new. There's nothing to judge you about whether it's came out failed replication or successful, p-value supported or not supported. But did you really follow the plan? Are your conclusions aligned with the data and so forth? So it doesn't matter for registered reports whether the hypothesis was supported, p-value lower than 0.05, whether it has impact or not, whether results are novel. All this doesn't matter for registered reports. So from all these problems, if we think about this, there's no publication bias because everything is published regardless of outcomes. So we eliminated this part over here. It eliminates all the problems with p-hacking and harking and all sorts of other issues that we have over here. And then if you talk to the reviewers and they have a problem with your power analysis or they think the sample is not large enough, they will tell you, and then you can do this before you collected the data. So there's an opportunity for you to get real feedback and improve before you embark. So all the issues can be addressed to begin with. So you eliminated all sorts of things like low statistical power, and then it incentivizes things like conducting replications, data sharing, open science. And then suddenly, for the first time in science, we're looking at this entire process as being green. So this kind of summarizes all the differences between what is a pre-registration that you do on your own and a registered report where the journals and the reviewers and the editors help you doing this pre-registration in the right way. Since 2013, it started with 3 journals that did this, but very fast, this kind of exponential growth, the good kind, not the COVID kind, that grows up over here. And now we're up to about 330, I think, different journals that embrace registered reports, not only in psychology, neuroscience, cortex, but across the different fields. So if you're from education, if you're from management, if you're from any other discipline, by now there's at least a number of journals that will embrace and support you with registered reports. I really like this slide from Chris Chambers. The original slide is only these at the bottom, and I added these two on the top. So I really, in my own perspective, when I see a current research published with no pre-registration, no open science, I don't know what to make of it. Does it hold? Doesn't it hold? Does it replicate? Can I assess this research or not? So I believe that this is barely worth a mention. If I see a COVID-related study that doesn't follow all of these things, I just don't think this is reliable. But if we have open science, this is already a step up. So I can evaluate this and I can look at the results. If it has pre-registration, so I know that they've uploaded this to a public website and then had other people look at their plan and then can compare what did they plan and what did they execute, then this is one level up. But the highest one over here is a registered report where everybody comes together to evaluate a plan, making sure that the plan is the best that could be, and then publishing this after, in principle acceptance, getting the data collected, and only then publishing the results. And the best standards, according to Chris Chambers, is a meta-analysis of registered reports. We also do a registered report meta-analysis of registered reports. So we're taking this one step up. that's for a different workshop and time for us to discuss these. But really, registered reports is where we should be headed. What are the advantages for science? Reproducible, high statistical power, transparent, credible, wonderful things. But not only for science, but also for you as authors. Because instead of getting expert criticism, very hostile reviews at the end, after you've already done everything and getting rejected again and again and again, instead of this, suddenly you and the reviewers work together. It's amazing to get this constructive, positive reviews from experts. The students are just like blown away because they expected to get a lot of negative feedback, but they get these world-class experts giving them tips on how to improve better. High acceptance rate, so journals that have adopted the registered reports, there's no reason to reject you because you haven't collected the data yet. If there's a problem, you just negotiate this and you get to the best practices and then you collect the data. So there's no reason to reject. So from 90% in Cortex, they went down to 10% rejection rate. So suddenly you don't need to submit again and again and again until you find a journal. But to begin with, you have one journal that works with you collaboratively in order to get this. And then there's no reason to reject. And 0% of stage 2 have been rejected, which is remarkable. So you get the paper accepted before you start the research. So already when you get your in-principle acceptance, you can put this on your CV, which for the students is terrific, or anybody on the job market or up for promotion. You can already show the journal accepted this. In addition, let's say that you don't have the funding to run the data collection, but you already have the in-principle acceptance. You go on Twitter or you go on a forum and say, I have an in-principle acceptance. Who wants to join me and has funding? Or you can go to a funding agency. You can go to the Hong Kong government and say, this is already accepted for a journal. So there's no need to bet on anything because everything is already well known. Plus, registered reports seem to be a lot better cited compared to traditional ones. I want to very quickly show you. I don't have a lot of time, so I'll just open this very briefly. So this is one that we've actually submitted today. So this is a registered report that I wrote with one of the thesis student wrote, and I guided. So what you can see over here is that this is a replication of a very famous review article by Thaler, received the Nobel Prize for Economics, so a behavioral economist. I hope that I'm getting some delays. Okay, I hope this is still holding. All right. Yeah, so what you can see here is this is when I talked about contributorship, this is what I meant. So this is what the student did, and this is what I did. And then the abstract, results are written using randomized data sets produced by Qualtrics to simulate what these sections will look like after data collection. And these will be updated following the data collection. So we write the manuscript as if it's a regular manuscript, but we don't have the results yet. So you can see that we've analyzed everything in the original experiments, and then we've added all kinds of different extensions. And then we said where we're going to open the data. And then the methods in the results section are written using these randomized data sets. So if we go to the results section, what you will see here is that all of these results are based on randomized data. So as if this is published findings with the real data, and after we get the in-principle acceptance, I just go collect the data, and then we replace the results with the simulated data with the real data. We write up the discussion, and that's it, and that's finished. So we take this, submit this as a registered report stage 1 to the journal. We get expert feedback, so they're able to see everything that we're doing. They have the code, they have the simulated random data set, they have the Qualtrics to see what it is that we're running. They give us feedback on this, we improve, and once we agree, in principle acceptance, and then following week, I collect the data. So this is just to show you how these, what this looks like. If we go back to the slides, where were we? Okay, so we were here. So this is Amy's. You can click on this, or you can go to any one of the other ones that were there before. But this is just a very brief presentation. Some people ask me, so how do we know the pre-registrations and registered reports really work? I won't go into this, but by now we have some evidence, very conclusive evidence, that things are going well with registered reports and they really improve things. For example, positive results, supported hypothesis in the standard reports are 95%, which is impossible. Like, it can't be. But with registered reports, we have a mix of some supported, some not supported. So it's much closer to the truth. It stops p-hacking. So after medicine started implementing registered reports, kind of like uploading plans to a public website, you can see it stopped p-hacking. So suddenly everything is around the null over here. But the most, I think, conclusive thing that I've seen so far being published is this one, where they did a randomized control trial of registered reports versus traditional reports. And you can see that the quality, methods rigor, analysis rigor, overall quality of the paper has been judged blinded, like blind judging of the quality. Registered reports really blow the competition away. So a lot of benefits for this. Some of my collaborators who did registered reports with me, so Krishna Savani, for example, is a full professor. He's now joining PolyU soon from Nanyang Technological University. And he said this was by far his most rewarding experience. Instead of second guessing, the editors and the reviewers, they tell us in advance what they want. So we don't need to overthink things. They tell us what we need to improve. So it's a rewarding research experience, and there's clarity. There's no second guessing. Chinyu, the MPhil student that I mentioned that did a registered report with me, said that this helped reduce uncertainty, much more confidence in catching the errors, has more peace of mind, saves a lot of time. The reviewers contribute more meaningfully to the entire process, and it really made the paper a lot stronger. And he especially recommends this for students and early career researchers. There's a big revolution. Let me just see. I don't have much time, so I'll try and wrap this up. But right now, what I'm doing with my students is using what is called Registered Reports 2.0. So this is really 6 months ago. Chris Chambers and a bunch of others came up with this initiative, and it's mind-blowing how well this works. So some of the benefits of this is that they guarantee a review within 2 weeks. So suddenly you can do this with your thesis students, the one-year thesis students. You don't have to, this is going to take 3 months, 4 months, will this come back in time or not? They guarantee, if you schedule this, within 2 weeks to give you a peer review. So you just need to look at the year, sit with the student and plan when will you be able to submit this, and then tell them this in advance. In addition, they make sure that the editors and the reviewers know and understand open science and registered reports. Everything is open and signed, including the reviews. You can even get a DOI for being a reviewer for registered reports peer community. And then you have this review with the peer community. So the community does the review. And then you, after you get your in-principle acceptance, you decide which of 30 journals you want to publish with, which is a remarkable revolution in science. Rather than committing to one in advance, you have the power. So it really changes everything about the way that we do. I won't go into this, lots of hidden slides. Please go and have a look. So just to recap, going back to this slide, now that we understand what registered reports are and what I've done with the students, this is where you come in. So you can join us, you and your students, or if you're a student, you yourself can come and join us to take part in this initiative. Instead of doing what it is that you're doing the old traditional way, just write the registration plan in advance and submit this to the journal as a registered report. You'll get some constructive feedback. You'll work this together with the reviewers and editors. And once you get an in-principle acceptance, if you meet the criteria within the domain, we'll fund your data collection. So this is an opportunity for you to, if you don't have your own funding for your own data collection and you want to do it this way, come and take advantage of what we're offering over here. Up to 30 students, student co-authored manuscripts. So has to be a registered report, has to get in-principle acceptance, has to have students, and has to support open science. And then I'll help, I'll guide, I'll conduct the data collection for you. It's first come, first served. So go ahead and start doing this right now. Hopefully, I think there are some decision makers here in the talk, or perhaps they'll get to this later. If this goes well, I don't see any reason why we can't just have every thesis in HKU or anything that we do with the students go through this model. And it's a very efficient model. Can you imagine that we only fund things that are already accepted, up to $1,000 rather than again and again running through process that takes years? So we can capitalize together on advancing science together with the students and making the most of the budgets that we have in the right way, funding what it is that we know is going to get published already. So hopefully after we have the 30, I'll be able to convince the HKU authorities to give us more money and expand these. We have a lot of templates, we have many guides. If there's something that you don't know how to do, I'll be very happy to work with you on this. If you want to join our team of 75 early career researchers, about 370 students, you're very, very welcome. We have a very long Google Doc guide on how you can do that. You can take lead over our completed replications. You can take lead over our register reports. So if you don't want to start your own project, you want to publish with us, you can do this. It will also save you time. You can collaborate with us on our guides and our templates, or you can suggest new directions. Everything that I just mentioned to you, our big mass replication project and all the work with the students is up on this link. You can have a scan of this QR code. And then finally, I'm very active on Twitter, so you can follow me and get some updates on that. We have a mailing list. So this talk, 2 other talks that I'm giving next week, I think at HKUST, the following week in University of Vienna, about how to work with early career researchers, the kind of revolution that we're having in science right now. You can stay up to date by subscribing to this mailing list. And then all the talks, after we share them, I also make an announcement in the mailing list. And my email is here. So if any of this interests you, if you need more information, if there's something that you want to try in your own lab, in your own courses, I really want to work with you. I think I was very excited when somebody finally at HKU was wanting to interact with me on this. So I'm very passionate about working with students, about doing open science, about register reports. So please do reach out and tell me how I can help you do better in your own research or your own teaching. So that sums up my talk. Happy to take your questions. I can see the chat has quite a bit.
Thank you so much, Gilad. That was very engaging and very, very interesting as well. So I think I will direct, Will, you did promise us that you can stay for a few more minutes beyond 5:30. So thank you.
As
yes,
long as you want.
Thank you for that. So I'll go through the chat. Maybe Xiaohu, do you want to ask your question first? So Xiaohu is from the Faculty of Education.
Yes, Ronald, thank you so much. And thank you, Gilad, for your wonderful presentation. It's very convincing that the registered report should be the way to go. There are so many benefits and so on. But at the same time, you also mentioned very few HKU students have gone into this path. So can you tell us what were the the factors that hold back people? So what kind of things that people would make people hesitate to do the registered report? Thank you.
That's actually a really good question, because I mostly see the benefits. I think, as a judgment decision-making researcher, I study biases like status quo bias and inaction inertia. So whatever it is that we're used to, or social norms, whatever it is that we see in our environment is the way that we usually like to proceed. And we stick to what's familiar and what we see works. Plus, I think there's a lacking information. So first, people don't know about this. If they know about this, they're a bit hesitant because this is very different from what they're used to. They perceive this to be a big risk. And third, I think there's a bit of an institutional pushback to this, because right now at HKU, our main emphasis is on these so-called top-tier journals. And right now, registered reports are, it's kind of like a grassroots movement. So I think in our field, if you're in social sciences, recently like Nature Human Behavior, JPSP, Journal of Personality and Social Psychology recently joined registered reports. So it's going slow. I have no doubt that it will reach the top journals, but it's not there yet. And some people, this is what they aim for. So I think at the beginning, you need to have sort of like a mindset of what your priorities are, or have a much longer term goal. I think if you're a student, it's easy for me to convince the students that by the end of their PhD, in 5-10 years, this is going to be very, very common. But some of them need to get promotion now, or they need to get, I don't know, whatever support from the institute, get into a tenure track or get into a postdoc. So they're feeling the pressure. And also they're having a hard time negotiating this with their PIs, with the professors that are mentoring them. So there's a bit of a misalignment. It's even beyond register reports. I'm having a hard time at HKU talking to researchers, scholars about open science practices. Students and the junior faculty are very enthusiastic, but when I get to the senior faculty, it always seems to be sort of like a barrier, a little bit of suspicion, hesitation. So we need to try and overcome this. I think in psychology, we're already on the right track. I don't think this is reversible. We're headed there. If you talk to education, if you talk to management in the business schools, if you talk to some of the others at our university, they're a lot more skeptical. I think they're like 5 or 10 years behind all the things that we've experienced in psychology. So for them, they don't even understand the need. It's like nothing is broken, everything is working as expected. So what's wrong? So only now cancer biology 3 months ago came out with these shocking results. Only now in management do we get these findings that there are issues with the management journals and we need to improve. So there's a lag. It will take some time, but I have no doubt that in 5-10 years, things are going to be very, very different in science. And registered reports is no longer something on the the side. This is becoming mainstream way of doing science, and now is the time to join this train and get on board.
Yes, thank you.
Okay, we have a question from Vivian. Vivian, do you want to ask your question to Gilad?
Yes, hi. Thanks, Gilad. Just wondering, would the journals which accept registered reports have a higher impact factor then, like in the long run?
So I personally have an issue with impact factors. I don't think they mean quality. I personally emphasize other things when I look at journals. So now we have what's called the top guidelines on how to make research more reproducible. And I really hope, so 2 years ago, HKU hosted the World Research Integrity Conference. This year it's going to be in South Africa. And because it was in HKU, we now have the Hong Kong Open Science Principles that a lot of others have endorsed, but HKU has not yet. Chinese University of Hong Kong has endorsed this, but not HKU. And one of the principles in these open science related principles is that we should assess researchers not based on what journal they are submitting to, but based on whether they've shared the data, they've did the pre-registration, they have well-powered samples and all of that. So we need to shift the way that we're assessing. Given that things are going to be slow at HKU, and I don't have high expectations of this changing anytime soon, I think with time, increasingly, we will see the high impact factors journals having to shift to the register reports, but I can see how they're using a more, let's say, exclusive version of register reports. So register reports in Cortex was meant for, as long as the research question is good, then we will go for it. But I can see how, let's say, Nature Science would say, I want this to be interesting and impactful no matter what the results are, so that I can embrace register reports. So for example, I don't know, treatment or which one of the treatments is the best for COVID. So having these kinds of randomized controlled trials or something of that sort. So it doesn't matter if the findings are significant, not significant, and all that will still gain something that would appease the nature science audiences. But it's getting there. Many of the nature journals are embracing this. It's not the case right now. So now it's more the lower tier, the diamond open access, the community journals are doing this. But I have to say, if these top tier journals don't endorse this, given that registered reports are being cited much higher, and I think they're much more credible. It's already happening. There's a shift in the way that citations are happening, at least in social psychology. So if they don't join this, they're going to be left behind. So give it 5-10 years, I think we're going to be in a different situation where registered reports and open science will mean also high impact and being assessed on that in order to get your promotion or get accepted to a job. That's my humble view.
Thank you. Thank you very much.
Okay, I know it's 5:30 already, but Gilad has agreed to stay on for a few more minutes.
Yes, happy
but
to.
For those in the audience who need to go because of your time, yeah, please feel free. We will be recording we have recorded this, and then we'll be posting it online. I want to draw attention, Gilad, to I think we have a question from David Edmonds. David, do you want to ask your question?
Oh, sure. Sorry.
No worries. Yes.
Yeah, Gilad, amazing, really interesting talk. I have so many more questions just in terms of, because I have a psychology background and I'm really into open science, so I've got much more questions, but I can ask those some other time. But I was just interested in, beyond just being useful as a way of introducing students to the publication process, I was interested in wondering about your thoughts about how undertaking a registered report might be valuable as a pedagogical tool for students.
Yes, thank you so much for this, because I didn't have time to go into this, and that's in the 3-hour lecture that I linked to. So you can go and get some more information over there. And actually, I encourage you to go and listen to the talks given by the students about what they went through and why this really changed their view of what education should be. And I should say that my view of what I should do in my courses really changed in my postdoc at Maastricht University, because they have what's called problem-based learning. Rather than us telling the students what the truth is and them, rehearsing this, memorizing this, and then dumping this on a multiple choice exam at the end of the semester, we pose a problem to them. In this case, it's, does this replicate? Or what is the answer to this research question? So we pose them with a problem, and they facilitate the journey of how to solve this. They decide what their learning goals are, they decide what their resources are, they come and they integrate all of this, and then they match the knowledge to the research question, and they come out with. So rather than teaching them this bit of information that I know, my biased view of the world, this is what I know, so you must know this as well, we teach them how to learn. They learn how to learn by going, how to seek information, how to solve issues. And one of the most important principles for me is to show them that I don't know the answer to these questions. I don't know if this is going to replicate. I never ran this replication before. Honestly, when I was given the advanced social psychology textbook and said, this is what you should teach, I'm like, I don't even know what I can teach from here. So rather than giving them something that I don't know if I can trust, I tell them, let's try and figure this out together. Choose one that is interesting for you, then we can try and embark on this together. You'll figure out something from the journey of trying to figure this out. You'll contribute back to the scientific community. So you'll be acknowledged as a person who did something meaningful. So lots of ways to grow from this. I want to just touch on one other thing, which I think is really important and we don't do in HKU quite enough. It's not just us and the students, the instructor and the students. We are part of a much larger scientific community, and we need to invite this community to join us. We need to invite the students to join that community. So by opening up everything, by sharing everything that the students are doing, by doing this, the reports on Google Docs, and then communicating this to others on Twitter, basically what we're doing is that we're telling them, you are now part of the scientific community. When they see, when they try and replicate a manuscript and they see the original author come in and comment on their Google Doc to try and help them, this just blows their mind. They never thought that during an undergraduate course at HKU, they'll receive feedback from someone who's considered to be a world expert on a certain phenomenon. So they engage, they learn, they build some ties. Perhaps later they'll want to go and work with this person. So we've had quite a few of these things where somebody who saw what our students are doing, gave them feedback, built a link, invited them to join later. So now they're not feeling alone. They're not feeling like what they're doing is going to be tossed aside and then they'll forget about this course. Everything they do contributes to the community. It's an ongoing, long-term relationship that they form with the people that are out there, that are not these names in an article, but really live people that are you can engage with and learn from. So I think that's revolutionary for students. I really wish I had this when I was a student. I think it's really empowering for them to see and learn.
Okay. We have a PhD student asking a question. So can I ask Norman, who's a PhD student, to ask your question? And then after that, I'll direct it to Peter, who has a question on the chat box. Yeah, Norman?
Thank you, Gilad, for the very passionate and inspiring presentation. 2 questions. First is, when you do stage 1 for the registered reports, is the IRB from your affiliated university necessary, or can they be concurrent? That's the first one. Second one is, are these, because I've seen your papers, they're really on experiments in social psychology. Can you also do registered reports for cross-sectional surveys or longitudinal surveys? Thanks very much.
Yeah, very good questions. Actually, you can do registered reports on almost everything at the moment. You can even have this on archive data. How is it possible? Archive data is already there. So what does it mean? So as long as you haven't run the specific analysis and perhaps you don't have access yet, but you will have access to the data archive, you can even do a registered report. For that, definitely cross-sectional survey design is a very common sort of thing, and you'll see a lot of, let's say, in personality, this is cross-sectional is very common thing to do. So definitely a very good way. We address this in a very, so it's easier for us, I have to say, because we're doing replications. So we repeat something that was already published. We have a very specific protocol. So if it was already published and IRB is less of an issue, sometimes we add extensions, so that might need, if there's a possibility of harm, to update some of the things after we design the extension. But for the most part, in replications, it's not a big issue. Plus, you can wait with the IRB before you begin your data collection. So you can go through the stage 1 prior to receiving an IRB, but I think in most of the places where I've seen, before embarking on the data collection, and in stage 2, they will verify this, you must receive an IRB. So one of the things that they will check in stage 2 is after you receive the in-principle acceptance and before the data collection, did you receive an IRB for this or not? But it's a lot more flexible. And I have to say that IRBs are a lot more welcoming once they've seen world experts, people that understand this, giving their stamp of approval. So that also something that is much easier because everything has been done. You have a plan, you know exactly what the Qualtrics is or the survey that you're going to run. So IRBs would be much smoother after receiving an in-principle acceptance.
Thank you. Thank you very much.
Okay, thanks, Norman. And Gilad, Peter, you have a question about reviews and timelines.
Yes, thank you. Thank you for the inspiring, your great talk. So I just have a questions about the time frame. So how long does it take the authors to receive feedback from the panel? If we actually consider the register report as a pedagogical methods, then I just wonder whether it actually can fit to the terms schedule. Yeah, so would you have any experience sharing for that?
Yeah, so I was struggling with this up until 6 months ago. I was not sure how to do register reports. So the only thing that I did with my students is that they write the register report stage 1 in the course. They finish the course, they go on. I recruit an early career researcher to take this together with me to submission, and then it takes whatever time it takes. However, I really wanted to do this with my thesis students. So one of the last slides that I covered, this peer community and register report, changed everything, which is why this year it's a proof of concept for us. I have 12 guided thesis students, which is a lot, but it's important because I really wanted to give this a try. About half undergraduates and masters. And looking at the the academic year. So supposedly, at least the undergraduates were supposed to, before the COVID update, to submit this in April 15. So we structured this in a way that up until April 15, we will get the in-principle acceptance. So in-principle acceptance, and then we proceed to the data collection, and they can write up the thesis and submit the thesis, and then we can slowly work with the stage 2 and the journal. So how do we get this magic to happen? And this has to do with the special track that they have in the peer community and registered report, which is called a scheduled track. If you let them know 6 weeks in advance when you need the review, then you can get a review within 2 weeks guaranteed, which is fantastic. So for example, what we submitted today, what I showed you from Amy, we'll receive so first they verify this. It takes like 2-3 days to make sure that everything is according to the standards that they have. Then they submit this to the review. Reviewers are supposed to give a recommendation within a week, and then it takes the recommender, the editor, another week. So within 2.5 weeks from today, we should be getting a decision on reject, revise, if revise, how. And the good thing about this is that it's also very constructive. So they tell you, if you do X, Y, Z, if you revise these, then it will be an in-principle acceptance. If you fail, then it will be rejected. But most of it is very constructive because you haven't collected the data yet. So 2.5 weeks review. You revise this, typically I would say a week, 2 weeks, depending on how large the requests are. And then the editor makes a decision within 2-3 days. So a very, very fast and efficient. And once you have the in-principle acceptance, then, collect the data, submit the thesis, take it slowly, and then submit the stage 2 report. So definitely we can do this within a single academic year. How to do this within a 3-month semester, I'm still not sure. Remains to be seen. I'll get the insights from the process of how I'm doing this with the thesis students, and then I'll think what to do with this moving on. Plus, with the thesis students, I can do a much better job because I guide them each and every step of the way. When there's a large course and there's a lot of people involved, I feel like the guidance is a little bit more, it's not as solid. So generally, perhaps we'll keep sticking to the original paradigm where they write the best that they can in the manuscript, and then I join an early career researcher, and then we submit this to a register report. But let's take the MPhil, for example, that worked with me. We submitted this at the beginning of the first year of the MPhil. By the end of that year, with a regular, not a 2-week scheduled, but a regular registered report process, by the end of the year, the MPhil student already had an accepted stage 2 manuscript. So we were worried at the beginning whether this is suitable for an MPhil for 1 year, but now we know that they're very, very efficient because the feedback is so constructive and so detailed that there's no reason for 2 rounds, 3 rounds, 4 rounds, but you can get through the whole thing. And if you're efficient on your side and you do the work well, and by now we have all the templates and we know how to do these, at least replications, we know how to do very well, then the process can be very, very efficient and can match what it is that you're doing with your research students.
Okay. Xiaohu, can I direct the question to you? And I think in our chat box, Arpita also has a question.
Hi. Thanks, Emmanuel. Hi, Gilad. From your presentation, I found many of these papers are actually joined by researchers in the community, and then they are the first author or co-first authors. So I was wondering, like, how do you ensure this process is fair? Like everybody contributed the listening author, and of course the most important, the first authors, they are actually fair to everybody. Thanks.
Yes, so this is something I've been debating for a very long time, and I was trying to understand what people would feel good about. So I think the students generally the fact that they have a publication is already above and beyond anything that I've ever expected. But still, you know, I know a lot of people who would put themselves as the principal investigator as first authors and let the students and everybody, you know, be in the back. For me, it's important that I'm always last. So I should give the credit to everybody else. I coordinate this, I guide this, I mentor them, but they should really get the credit. The early career researchers, beyond, you know, verifying what the students did, they contribute a lot. So the nice thing about doing open science is that you can actually take any of our projects and see the evolution of the manuscript from what happened with the students until this was accepted for a journal. And these early career researchers, first of all, they take a huge risk, because who are these Hong Kong university students? Is this good or not? Is this going to work out or not? Students have zero risk. They took a course, they got a grade, and now they graduated, you know, so everything is good. So I wanted to reward this risk, and I wanted to reward their contribution. And in the most part, what they contribute is invaluable. So I decided that early career researchers, at least in the order, are first, followed by the students. But it's very important for me that all of them are shared first author, to say that all of them contributed. Then the teaching assistants kind of as the guides afterwards, and then me treading in the back. What you might have seen, it was very, very brief, but in each and every manuscript, we have a very detailed list of what each and every person did in this project. So it's very clear, the students did this, the early career researcher did this, the teaching assistant did this, and this is what I did. So I think increasingly we're moving towards that model.
May I be more specific? So then, as we know, we have two stages. So the first stage review, would the earlier career researchers involved in the first stage review, or only after the first stage review?
Yeah, definitely they involved in the stage one. I will not submit a manuscript unless it's a thesis student where I am involved and guide them. If it's course-related students, I will not submit these manuscripts unless there's another early career researcher to verify everything, integrate, and make sure it's submission ready. So definitely stage one, they are involved, they lead the way, and they also want to have their own input. Sometimes they add their own extensions, sometimes they add their own analysis. You know, some of them are Bayesian instead of frequentist. So definitely they want their voice to be heard as the lead authors, because at the end it will be their last name et al. Right? So they really want. However, since you brought this up, I feel like it's important to say, many times we submit a stage one, and then it could be happened that the early career researcher left academia, or the students, you know, lost interest, or something happened in the process, or we didn't have funding. So we go up to Twitter and we say, we need help with this. Perhaps we need somebody to lead this. Perhaps we need someone to help us with data collection. And then we need to negotiate kind of like what is the right way to include you as an author. But in these cases, it's less so with the students, because they can't be involved in all of these. They gave permission, you know, coming into the course for me to handle all of this for them. But I keep their best interests in heart. Is to make sure that everybody gets the right according to their contribution to the entire model. But it could be that people are added in stage two that were not involved in stage one, and this typically happens because the people who were in stage one, it took too long, left academia, lost interest, whatever, and then we need to involve other people. But it's possible. It's possible to involve others in stage two for sure.
Yeah, thank you. That makes sense. Thanks for the information.
Can I ask Arpita next? Gilad, you're so popular. People are over time for you.
Great.
Yeah, Arpita, you want to ask your question?
Yes, sure. Thank you. Thank you for this presentation, Gilad. Yes, I have been following you since the last HKU talk, and this talk, I see a huge improvement and great success. Congrats on this, bringing to thesis level. So my question is, now that I already have a pilot data, and could I still go ahead and register my study and conduct the actual study? Because for experimenting, I really need to check again whether this experiment works and things like that in terms of reaction time, fixing the bits.
Yeah, for sure. So I think the most important thing about registry reports, or generally about science, is that we're transparent. So you're transparent that you ran some pretests, you have some data, but you want to do something else. And what you're aiming for is to get the peer review and the community or the journal to evaluate what it is that you're planning ahead. So being transparent about what you've done, where you're at, how this contributed to your current plan, and then looking forward about the data that you're going to be collected. Now, the nice thing is that the top guidelines, and if you go in the peer community and register reports website, it's super clear that they have levels. So they have level 1, level 2. Level 6 is the highest, where no data has been collected yet, and no data exists yet, and everything is in advance, written as confirmatory for when you will receive data. If some data exists and you want to include that in your register reports, perhaps you'll need to go down to, let's say, level 4. So, for example, I was a little bit worried that with my thesis students, we will not have enough time because they need to graduate and do their thesis. So I asked the register reports folks, if I don't get a decision letter from you with an in-principle acceptance by this date, I will have to collect data because the student needs to graduate. And then they said, no problem, as long as, of course, you tell us what you're going to do. We might need to adjust this from level 6 to level 4 or 3. So the fact that a data exists or you've done something is terrific. It doesn't mean that the science is not right. It just means that you need to be transparent about this, and that you'll need to adjust the level of let's say strictness of what is it that's involved in this research. So go on the peer community and register report websites and look at level 1 to level 6, and that will become clearer. If you can't find this, just send me an email and I'll send this to you. It's very easy.
Sure. Thank you. Thank you very much.
Okay, do we have other questions from the audience still in this room then? I think William a while ago has a question about the rejection rates. His mic is off, so I'll ask the question on William's behalf from Faculty of Education about the rejection rate of 10% in Cortex. So does that include, I think William's question was that whether that includes test rejections or not?
I don't remember, but Chris Chambers is super responsive on Twitter, so you can ask him directly. Plus, by now you have rejection rates for many of the journals that do register reports. I think that at least things like peer community and register reports don't really have desk rejection, as long as you did things according to a certain format. So they leave the decision of whether this is, I don't know, let's say a contribution or whatever, for the journals who come later. For them, it's like they want to focus on the science. So you have a research question, and then you have the methods, the hypothesis. Then you have your much later the data and the way that you analyze the data. So rejection rates typically are for desk are not high for things like peer community and register reports. And I think especially with Chris Chambers, who doesn't think of a contribution the same way that I think most journals do. However, if you submit a register report, let's say in our field, psychological science or JPSP or nature human behavior, really care about the contribution, and they pride themselves in a desk rejection of 60 to 80%. So only few of them go past that, and then you need to go past that barrier. But this has nothing to do with register reports. It has something to do with the way that they evaluate contribution. But generally, once you pass that contribution criteria for these journals, the rejection rates for register reports are so much lower than the traditional one, because there's really no reason to reject everything. You can just discuss and then correct.
Okay, thank you so much. I think we've already taken more time than you promised. I think you deserve a good evening in Bangkok. So we'll definitely, what we'll do is as I said, we've recorded this, and hopefully the undergraduate task force led by our Vice President, Professor Ian Holliday, can invite you to speak with the task force members about, as we plan ahead for undergraduate research more broadly in Hong Kong U. So I hope you'd accept that invitation, and we'll send you the timeline later once we've ironed out people's schedules.
Terrific. Thank you so much.
Okay, thank you so much, folks. So again, thanks to everyone for staying 25 minutes over time. So we'll close this session. And if you want to email Gilad, please feel free to email him. Or if you want to pass it through us at CETL, we'll be happy to do so as well. And our next talk will actually be from Nanyang Technological University by Adam Schutzer, and I hope you guys can attend. So again, thank you so much. Bye-bye.